All right. Good morning, everybody. Hello. While the last people are still coming in, I'm short on time already, so I'm just going to get started, I think. Welcome, everybody. Thanks for joining my talk. I'm going to present a little bit of a story about ING, the bank. The previous talks were a bit on the tech side, so I'm trying to also mix in a bit of the technology, because I think that's also what you're here for. I also want to show a bit of the use cases of ING when it comes to data science. A bit about myself. I've been working at ING for over 5 years now. I'm a tech guy. I used to study artificial intelligence. So I've been in this industry for almost 15 years already. 10 years ago it was still very vague and obscure, and nobody was talking about big data yet. But of course now the hype has arrived, and we're here at Big Data London. We have huge amounts of people working in big data. So I enjoy being in this industry actually again, and relearning and reiterating what I've been learning in my college years actually. You can find me on Twitter, LinkedIn, etc. I'm happy to connect, so to share ideas, and please do. I want to talk about ING a bit first, because I think it's not so known maybe here in UK, because we don't have a retail bank here in UK. But actually we are one of the biggest banks in Europe, and also one of the best banks in the world, because we won an award last year and the year before that actually already. And I'm going to tell you a bit why that is, hopefully, and why I'm quite proud of working there. And as you see, the orange countries here on this list are the countries where we operate as a retail bank. We are based in Amsterdam, but we serve millions of customers across Europe and also Australia in retail banking. So if you go to the vision or the strategy of ING, what is this? So this is the strategy on a page. And actually the top strategy line that we have is that we want to empower people to stay a step ahead in life and in business. And that's already, maybe different from what we call a traditional bank or from any other bank, because that statement doesn't contain any banking products. We don't say, you can get the best mortgage or the best credit card at ING. It is we want to help people in their life. And of course we have financial products for that, but that's not the real purpose of the bank. And it becomes even more interesting if you read the strategic priorities of this on this page. Right here on number 2, I'm going to point this out, but number 2, it says we want to develop analytics skills to understand our customers better. So analytics skills, that's big data, right? That is data science, big data combined. And that is right on number 2 of our strategic priorities. And so this slide is not the priorities list or the strategy of the data science department. It is a strategy of the entire bank. Because ING has realized that banking is changing a lot, actually. In the traditional old days, and I'm talking way back, the purpose of a bank was to store money. Now you see the picture here of 1858. That's one of the first banks in America, where Wells Fargo opened an office building for the gold miners in the gold rush to physically bring their gold, and they kept it safe. So while the gold diggers were out in the mountains and searching for new gold, they hold on to their property. And when they got back, they paid a little bit of interest, and they could take their money out, and you could spend it and get rich. That was the traditional purpose of the bank. In the recent years, that has changed tremendously, of course. The offices stayed, but the money became digital and virtual. We still have cash, we still have notes and coins, but actually all the payments are being done in a virtual way on the internet. But still, I'm still from the age that I went to a banking office, for example, to get cash out every week or every month. And that cash was what I used to pay in shops and in a pub, and any other ways that was possible. My salary was arriving there digitally, but I took it out in cash. But that has also changed, of course. Who is visiting a banking office now, a branch? that's not so many people anymore. Maybe if you want to get some advice, maybe then you visit an office, or maybe if you need to get a new card, a new credit card there, or you have to register for a new product, something like that, then you might visit the branch, but you don't go there anymore to do your day-to-day business. Everything is on the app now. Everything is digital. And to quote the previous speaker, Elliot of MongoDB, your business is an app. That's also what we realized. The primary interface that we have as a bank with our customers is the mobile app. And even that goes so far that people reach out onto their mobile phone to get a mortgage, which was unthinkable like 10 years ago. Why would you, that's such a complex product. It's just an important step in your life. You're buying a house. That's only, you do it maybe 2 or 3 times in your whole lifetime. Why? So I want to invest in this. I want to spend my time talking to a physical person, getting advice from it. Yeah, sure, that goes for a lot of people, but there's also a lot of people who think, okay, I want to just do it quickly, easily. I want to get all the knowledge myself, and I want to do it on my phone. That's how the young people actually think nowadays. That's the only interface that we have of them. So what does it mean for us, for our products actually, for our use cases? Well, a lot of things will change, but a lot of things will also stay the same. We are still a bank, so everything that was a priority 10 years ago, the security and the reliability of our systems, the robustness of all the transactions that we have to provide are still there. So they still have to be there. So whatever nice big data algorithm or tool or platform you can think of, all the security, all the metadata management, all the privacy, of course, of the customers has to be in it. So that's already something. But next to that, we want to be more predictive and personal for people. Hey, on the right side, you see a few of those terms. We want to be relevant and personal for customers in a digital way. Because if the only way that people are interacting with us is through the mobile app, then that app has to bring the best user interface and the best customer journey, as we call it, as in the old days, as if you were talking to your private banker or to your personal advisor in the banking office. Because if you do that in the right way, then people would like it and they will remain your customer. Yeah, so the key to our success is to become as personal and relevant to our customers as in the old days, but to do it in a digital way. Well, that's all nice said and done, but I have some actual examples of this, luckily. And then after that, I'll move into the technology bits. One example is this. It's a feature in the mobile app that is now being used by almost 2 million people in the Netherlands, which is forecasting your transaction data. We call it kijk vooruit, which means look ahead, because a lot of the traditional ways that traditional apps that you have, if your bank provides a mobile app, which is usually the case, they only let you allow to look backwards in time. They give you a historical overview of your money transactions, what you have been paid and what comes in. We said, okay, that's nice, but we actually, why don't we offer a service that allows people to look into the future? So we built a feature in the mobile app that once you log in, you can actually get a prediction of the money that you will be spending and that you will be earning in the next month, including a forecast on your new balance. So where you can scroll in and you can say, hey, oh yeah, I want to buy a new iPhone, but I forgot actually that my rent is due and I have some other bills to pay, so maybe I'm holding this off for a moment. And this is the way this is a good example of the way that we want to interact with our customers. We want to give them relevant advice, real time, based on their personal data, and actually give them an extra service, and which is not not just the product itself. The product itself is your bank account, but this gives an additional insight that people really like. They really use it a lot to do their financial management, basically. Another example is that we give some small pieces of advice again, which we call Actionable Insights, based on the data that we are analyzing of the customers. For example, the example here is it's time to pay your mortgage. Hey, we know that there's a future transaction coming up, again, based on a certain forecast of your data. And, but for example, we know also that you don't have enough money on your accounts to pay for it. So what will happen, yeah, if you don't act now, your mortgage will not be paid, and you will have a default in your bank, which will mean a red flag and saying, okay, this is a customer who might not be able to pay for his mortgage. We put them under a magnifying glass. So to prevent that, we give this customer an actionable insight, saying, please be aware, this is going to happen. Do you want to pay some money, transfer some money from your savings account to your debit account, because that would allow you to pay for your mortgage. And then the customer might say, hey, that's great. Thanks, ING is helping me. Yes, I want to do it. Or he might say, yeah, I know this already. Don't bother me again. I'm snoozing it, or I'm swiping it away, and just ignore it, which is also valuable feedback for us, of course. And I'll talk about this feedback loop a little bit later. Final example that I have with all this data science stuff that we're talking about is Jolt. And I bring this up because it's not ING branded, as you can see, but it's actually something that we built in Amsterdam for you guys, for UK people. So go ahead and pick up your phone and download the app now, because it's free. And it's something that we built that is what it actually is. It's an aggregation app. So no matter where your banking account is, Barclays, HSBC, or any other UK bank, we gather all your accounts into one overview to give you a full insight in what your financial situation is, including savings, credit cards, mortgage, everything like that. You can group like payments together to see actually what your monthly spending is on certain categories. And we also give you some actionable insights, again, to give you a little bit of financial advice. So this is an app that we actually will roll out across Europe, but we started in UK because open banking is here. Yeah, it's a big thing over here. So it was a good market for us to launch this app. Right, so did we build all this? Well, big data, that's going back again to the definition of this. The 3 V's, everybody remembers them: volume, velocity, variety. If you can combine the big volumes of data that we have, which we have, of course, at the bank, because we have customers that go back 30 years, with the fast data, what we call the velocity of the data that's happening right now, real time, then you can actually offer these kind of services. We can make a prediction on what's there to come in your spendings or in your behavior, if we know what kind of customer you are. So we know your age, we know where you live, we know what kind of products you've had in the past, all the big data, so to say. Combine that with the real-time transactions that you're spending now, or the behavior that you show on the mobile app, or even things like the stock prices, which we gather data from. Because we also have customers that don't have a bank account, but they are using the stocks to invest. So this is easy said and done, because what it comes down to is that you have to somehow magically combine your systems of records data with the incoming streaming data into like a magical analytical engine to provide some kind of insight to the customers. And I think maybe the architects realize a bit of the Lambda architecture here. That's the pattern that we still value a lot. So we are talking about the 2 V's actually of big data, volume and velocity. If we can combine that, then we are able to offer great services to our customer. So what we did in the first place, when it comes to big data, the big volumes, we built something called a data lake. And a data lake is, there's a variety of definitions for this. What we call the data lake is not just a Hadoop cluster, but it's the entire combination of a Hadoop cluster indeed, where we store raw data coming from systems of records, and we also transport it into a data warehouse structure, and we also combine it with some analytical tooling to present and display the data and to make it available in APIs and in our applications. ING was lucky enough to start this trajectory already 4 years ago. And actually, in fact, we spent quite a long time building it, but we now so far that we actually can say that the data lake is our single version of the truth for all the core data that we have in the bank. So it was a big journey. Setting up the whole technology stack is also already one thing what takes a lot of time. Then filling the data lake, with data is already a huge effort, but it really pays off. Because we could have also made the choice to not start from scratch, which we in fact did, but to, for example, keep on improving what we already had, because ING had data warehouse systems. We had a lot of Oracle databases. We had a lot of BI systems. We had a lot of SQL and Bash scripts that transport the data somewhere. Well, actually, it was a big mess. It was legacy. So then we said, okay, yes, we know it's going to be a hard journey. It's going to take a lot of investment. But let's take the best of breed from the technology which is now out there, and let's start from scratch and build a new data lake. So we chose a mixture of open source and vendor products for this. Hadoop, HDFS to be absolutely sure, because we don't use MapReduce. HDFS is used for file storage, which is the first step in a data pipeline. So every system, every core system, and we have hundreds of them, they produce a file on a daily basis usually. Sometimes it's more, but it's usually on a daily basis with their latest database export in it. We take on all those files, we put them in a raw file storage, and put them in an archive, all based on Hadoop. So distributed, big data storage, etc. That is already a valuable step that you can take if you want to enable data science and like analytics in your organization, because that will be already an historical overview of what your company, your enterprise data is like. But it will still be very difficult to query, of course. It will just be a bunch of files. So your data scientists will spend huge amounts of time writing interfaces to those files, getting the files, cleaning them, combining them, etc., etc. So the next step that we actually did, and this is all connected with ETL processes, is to transfer those files into a structured data vault construction. And data vault is again a file, you could call it a schema, a database schema that retains the history of all the records that you have, but also kind of a queryable schema for analysts and data science to have. So that's our enterprise data warehouse. We store that in Netezza. And Netezza is the old name. It's now acquired by IBM. It's called IBM PDA, which is actually just an extremely fast and big database. You can buy it in a box. So it's like it's a container full of hardware and software on top of that, all integrated to provide you the best speed possible. Nowadays you have also other solutions for this. There are also other appliances, and there's also extremely fast databases that also work on-premise or in the cloud. We choose this technology because at that moment as well it was one of the best and fastest database technologies out there. And then we move on, because then your data is in a structured format, but it still contains all the history, but it's still not really queryable enough. So the next final step is to move away from those data vault constructions and put them in data marts. And a data mart is basically again a database schema. It's usually a star schema that structures your data in such a way that it's easily queryable for reporting and for APIs. Which again are, for example, segmented. For example, we know that a certain finance report needs a certain query every week. Okay, then we build a data mart for that, so that it can prepare the data in a very efficient way, and the data is queryable in a quick way every week whenever it's required. Again, for another example, for example, the API that we use from the app to make the forecast of the transaction of customers. Yeah, we know that requires a year of historical transaction data, because that is what we use to analyze the data from the customer. But we only need the customers that have actually opted in to use this service. So for the other customers, we don't need a data mart with all the customers, all the transaction data. We only need a subset that's easily queryable from the API to gain the performance there. Yeah, and you see a bunch of tools on the right side. We are, yeah, again, we are using a mixture of open source and vendor products, including SAS, Cognos for reporting, Spark for analytics, and we also have a bunch of data scientists that use, yeah, whatever they like basically. They can use Python with all the traditional machine learning libraries like sklearn, pandas, NumPy, etc., or even frameworks like R, which are more statistical oriented. Our goal is basically to offer and to support any kind of technology that data scientists want to use to get the best prediction out. Okay, one other platform I want to mention is the streaming data platform, because this can be used for the majority of the high velocity use cases, like the real-time actionable insights that we generate for a customer. I'm not going to explain everything in this picture, but basically what you have, if you have a huge amount of events coming in, because it's all related to event-based data, and our events are transactions that are being paid, they are the mouse clicks that we register, the clicks on the app that people do, the behavior there. Millions of events that come in every second, and basically the goal is to funnel it into a certain way so that it actually produces one or two meaningful outcomes for one customer. So there's a three-step approach that we use for this. The first one of that is complex event processing, which is an extremely important step because this allows you to gather all your events and to make sense out of it, basically. We also see that we generate something called a business event, which is actually a trigger that indicates that something interesting is happening. For example, a customer is running out of money. That's a business event, which we have detected from a complex event pattern. When we see, for example, that the amount of money that somebody has in his bank account is rapidly declining. Another pattern that we can detect, which I haven't talked about yet, is fraud. We also use this system to detect fraud cases. So a pattern that we could detect is somebody is spending too much money or gaining too much money, which is an irregular pattern, and anomaly detection in fact, which can lead to us blocking the transaction or at least calling up this person and say, hey, something shady is happening on your account. There might be a fraud case there. The next thing after we've detected this kind of patterns is that we actually want to do something with it. And we want to predict what comes next. The next best action in marketing terms, or the action that we take. Should we call the customer? Should we send them a push notification? Do we send an email, etc.? That's happening in a machine learning execution engine, which runs these models in production based on streaming data. And of course, at the end, we do some post-processing, so we actually generate the next event, and we, for example, signal this actionable insight actually to the customer. We create a push notification in the app, or whatever action we can think of. So the technology stack that we use for this is based on Kafka and Flink. And if you want to know more about this, I can talk about that also for a while, but don't have time for this, unfortunately. One crucial factor I also want to highlight in all these machine learning use cases that we have running is the way that we operate. And first of all, our data scientists are being trained, you could say, or are being, the way that we use them is not just to sit in a corner and produce some models and write some Python code. It's actually that we try to involve them in discussions about the business case. For example, this is an example. I recently had a discussion where we want to improve the credit scoring of customers. Because if somebody wants to get a loan, then we need to determine how valuable this customer actually is. How likely is it that he will not be able to pay for his next loan redemption? Yeah? Because if that's the case, then we might not offer him a loan. Well, we sat together with data scientists, we came up with basically this structure. Because actually what we want to target is what we call the affordability of a loan. And if you break that into steps, then you can say, hey, what we actually want to do is we want to compare the monthly income of a customer to what he is monthly expending, the expenses in certain categories. For example, the regular expenses on his loan or his mortgage, or on his rent, or maybe he has other debts we care about. So that's the real important value to what we want to detect. And then we go one step higher. We say, okay, how can we extract that from customer data? And hey, why don't we label transactions? And for every transaction that comes in, we try to predict what it is. Is it an income or is it a debt? And by summing them up, we can come to the conclusion of the monthly income and monthly expenses, which leads to the total picture, the total affordability of the system. But this is what we do. We actually label transactions. We just analyze the transaction. We see, we compare the dates, the recurrence of the transaction. We compare the description of the transaction. We compare the height, the value, of course, of the amount of money that's involved. And all these lead to certain features that we are using in a model to say, yes, this transaction is an income, this transaction is somebody buying lunch or groceries. We don't care about that. Hey, but we do care about the next one, which is somebody has a car loan and he's now paying a monthly amount to reduce that car loan. But this is the way that we try to engage with data scientists. Well, this is, I think, a standard picture of how we do that, because you can just not just let data scientists loose on a set of data. What you want in the end is that you want a model that runs in production. And because we also learned that, we used to have a data science team that was completely separate, and they created all kinds of great models. But the models were only being used like once or twice in a report or for one analysis. And then data scientists moved on. The team was back in the old modus, and they built a great model, but it's not actually being used. So to build models that actually run in production in the mobile app again of the customers, you have to keep on learning and training on the data that comes in. And so there's a natural flow in these steps. First you want to create a model by training it on a certain training set, then you want to test it, you want to evaluate it, and then you actually run it in production based on the new data that's coming in. And then you can go one step further, because based on the data that comes in, you can actually ask feedback of the customer. And like I showed you with the Actionable Insights, we always ask of the customer, did you find this a good insight? Do you want to make use of this? Or not? Do you want to, get rid of it? It's also valuable, because that feedback is, again, a feature in your model, which leads to a new improvement of your trained model, actually, in that sense. Which again leads to a more personal and relevant experience for these customers. Because this feedback is personalized, of course. It doesn't get more personal than that. So if you have that loop really going on and working continuously, then you're really talking about reinforcement learning, and some people actually call it artificial intelligence. Last slide about the way of working also is that we also reorganized the whole bank. So 2 years ago, my job was cancelled basically, like everybody else's. And said, we are going to do things differently. We don't have traditional silos anymore. We want to integrate all the disciplines that we have into one squad, into one team. So we looked at companies that also do it like this, startups, and we said, okay, why don't we restructure the whole bank? We say we don't have a marketing department anymore, no product development anymore, no IT effect anymore. We just have squads that build a certain feature. So every team that we have is built for a certain business purpose, a feature. And the teams that are, and people that are required in those teams, are multidisciplinary. Sometimes we have 2 data scientists, 3 engineers, and 2 customer journey experts. Sometimes we only have IT people, but apparently that is required to build this feature. So depending on every use case and every feature, we collect a bunch of people together that can do it, that want to do it, and together they sit actually, at one space. So actually the data scientists don't have their own department or building anymore. Everybody is gathered around on the same tables, working on the same feature at the same time. And that's a real benefit of if you want to do it like this, because data scientists have short lines of communication to the engineers and to the business people, and the iteration starts going, and actually everybody will be involved in the end goal, which is what you want to achieve. All right, so this as a summary, I talked about what ING is. I hope to give you a bit of the the picture of what we do as a bank. Of course, this is just a small part of it. We are a data-driven organization, and we try to become it even better. We are using several technologies. I explained the data lake, streaming data platform, and give you some example of the machine learning use case that we have, the data science use case that we have. So I hope you learned a bit from it. Maybe you got some inspiration to do something like this yourself, or maybe you think, okay, this is not for us. Okay, that's also fine. But we've set into this route, so to say, with ING, and we are definitely going to continue with that. So that's also why I wish you all a nice future. And if you want to work for us, then come visit me or visit our job application site. Thank you very much.